We are now in section 2.2 where we've been studying the concept of limits. As x gets closer and closer to some limiting value, what is happening to the function? What value of y is that function approaching? So right now, this example 9, which is on page 16 of your notes, we are looking at limits of polynomials. And you can see in this theorem, the limit of a polynomial is really easy. If we look at what the theorem says in its conclusion, the limit as x approaches some number c of a polynomial function p of x is just equal to p of c. So polynomials are really easy. As long as we recognize we have a polynomial, then all we do is plug in the value that x is approaching, and that's the limit. So these are examples of polynomials, right? We have in part A, the limit as x approaches 2 of the quantity minus x squared plus 5x minus 2, which is a quadratic polynomial. And in part B, we're changing the variable to s, but there's nothing different here. We're just using the variable s instead of x. The limit as s approaches 2/3 of a factored quadratic, but it's still a quadratic polynomial. Okay, so in both of these, all we need to do is plug in the value that in part A, x is approaching, and in part B, that s is approaching. So these are simple to evaluate. In part A, the limit as x approaches 2 of the polynomial minus x squared plus 5x minus 2 is equal to, just plug in this value of 2 in for x. So minus 2 squared plus 5 times 2 minus 2, you simplify, you get 4. The limit as s approaches 2/3 of 8 minus 3s times 2s minus 1. Again, we just plug in 2/3 for s. We simplify, we get minus 2.